Alright, so this video is an introduction to the C++ programming language, and it's intended for people who have never programmed before, so we're going to go over some of the basic things that you probably want to know for making your first program. And that includes setting up your programming environment so you can actually program, what the main function does, printing to the console, introduction to variables and constants and their basic data types, and then documenting your code with comments. So for setting up, you're going to want a code editor. I'm going to be using VS Code or Visual Studio Code because that's what I'm familiar with, and I recommend that for you unless you already know something else. The link to the website will be in the description. And once you have that installed, go to the extensions tab at the side and search for C++ and install both C/C++ and the extension pack. And there's an image showing those two things if you're not sure. So follow that. And then after you have that set up, you're going to want to make a file. So depending on whether you're on Mac or Windows, you're going to either use the Command or Control and the N keys at the same time to create a new file. That's the shortcut to do that. And then once you have that, do either Command or Control, depending on whether you're on Mac or Windows, and the S keys at the same time to save your file. And when you first do this, that'll be like saving it as. It's like you pick your name and you decide where to place it. And the name doesn't really matter that much. Just make sure it ends with the .cpp extension because that denotes it as a C++ file. But it may be a good practice to start naming it as a main.cpp for when, if you start to work with multiple C++ files again at some point in the future, it's good to name your whatever your main function is as main.cpp. And of course, saving your work frequently is a good practice. Yeah, and on that note, let's do that. Let's do that now. So I'm gonna pull up VS Code and Command N, new file, Command S, main.cpp. See, and take note of where it is. I have it in this folder, the same one as this presentation's in. So I'll save it there. And you're going to open your terminal. And if your terminal isn't already open, you go up to the top here. It says terminal and put new terminal. And you're going to make sure you're in the actual folder where this program is. Otherwise, you're going to have problems when you're trying to run it and stuff. So to do that, you're going to use this cd command, which stands for change of directory. And you're going to go to your path, your file path. So I know I'm in my user now, so I go desktop, and that I have my, I don't even remember what it's called, hold on, subjects. And I'm using slashes between each file path and the path. So next, computer science is what this is in. When you have a space in there, make sure you have surrounded by quotes like that, and then another, and then to see, I think this is right. Yeah, okay, there we go. So now we're in the Welcome to C++ folder, and let's see, subjects, computer science, welcome to C++. And we're in here now, we just put this file. So now we're going to actually write some code using this main function, which is where the program will start executing from. So you're going to have two curly brackets, and that's going to enclose your lines of code. And those lines of code will usually end with a semicolon most of the time. And that's probably one of those common errors you make at first, is that you forget the semicolon at the end. So it's common. Yeah, anyway, the last line before your closing bracket should be return 0, which will indicate that your program terminated with that issue. So let's do that now. Okay, so now we're in here, and we're going to do int main, and then our brackets, and then return 0. And then we're going to Command S it to save it. So yeah, now we're going to compile. We're going to see how to compile. So for the most basic compilation, you're going to enter the following command here. G++, whatever your file name is, .cpp. But if you want to get a more detailed compile that gives you more warnings and to help you diagnose potential problems, you can use this extended version below, which I'm not going to bother saying. I'll have both of these in the description too, so you can copy, paste them, and then after you use them once, you can use the up arrow to use them again if you need to. And also you can use, instead of your file name, you can use asterisk.cpp to avoid always having to change the name of the file whenever you're switching files you're compiling. And then once you have it successfully compiled, there will be an executable file created with that. And depending on whether you're on Mac or Windows, you're going to either type ./a.out or ./a.exe into the terminal. So let's do that now. And let's see what happens. See, I already have this. Yeah, here we go. Compiled. So we have an executable file now. In fact, let's look at that. Yeah, this is our executable file, a.out. I'm on Mac, if you haven't already noticed. Yeah, now we compile, and nothing happened. What's the deal with that? That's because we didn't actually put anything in there besides the return 0, so it just immediately terminated. So if we want to see something happen, we're going to actually need an output. And the most basic version to do this is to print to the console using a.out, which is short for console output. And when we combine that with the stream insertion operator, which is the two less than signs, it'll output whatever's to the right of it. And there's an example below, which is what we'll probably copy paste in there. And also, and of course, some important way to note, if you want to use things like a.out, you need a preprocessor directive to do it at the top of your code, which I will show what you need. Yeah, let's do that now, in fact. So first I'm going to actually copy this line. And then at the top, before our int main even, we're going to do pound include iostream, and then using std, short for standard, a.out. You don't technically need this line here, but if you didn't, you'd have to use std colon a.out every time you introduce a.out, and I find that rather cumbersome. So I'd recommend doing it this way. So now that we've done that, we can actually use the a.out in here, and we can copy paste that. Let's see, make that look nicer. All right, save that. Oh yeah, by the way, you want to before you compile, you actually want to save your file, because otherwise it's not going to have those changes. So make sure to save before you compile to see your new changes. So now we're going to compile. Uh-oh. Maybe I shouldn't have copy pasted this. All right, let's actually type this out. I'm a professional, guys. I'm a professional. Let's see. I'll just type. All right. Want a lesson there for myself. Don't copy paste from a PowerPoint. Also, I misspelled hello world, but that's fine. So yeah, the hello world is usually what you're when you first learn a language. That's what you first learn, to print out hello world. So that's what we'll do, I guess. And yeah, hopefully we don't get those errors again. And by the way, this \n, that's not part of this, like what's being printed out. You won't see that. It's actually a special character, and you can see it's a slightly different color. It's this orange rather than this red, and it's a new line character, so it's going to automatically print out a new line. So now let's compile. Hopefully nothing bad will happen. Yep. Now if we a.out that, hello world. There we go. And this is looking pretty messy now, so you can do the clearing your terminal to make it look a little nicer. So now we get to talk about variables and constants and the difference between them. A variable is a named piece of data assigned to a certain data type and value. The value can be changed later, and it does not need to have a value assigned when it's created. An example int number equals 43. That's and then another one, you got int other number not being initialized at all. And then next is the constant, which is similar to a variable, except it must be initialized with a value, and that value cannot be changed afterwards. You want to use const before the data type to declare it as a constant. An example there, const int number or num of steps equals 101, and I'll go on to the reason why it's in all caps later. But before that, you're going to want to probably put your constants before your main function. So yeah. Of course, you're probably asking what all that stuff means if you've never programmed before. So let's take a closer look at one of those examples. The int number equals 43. So first the int. The int is the specified data type, which is an integer in this case. And the data type is only specified when a variable is first being created. You're going to want to leave it out afterwards when you're using or updating the variable. So here under we can see number equals 288. That's like updating the value. We don't need it. It's already known to be an integer, so you don't need to declare it again. In fact, you shouldn't declare it again, otherwise you get an error. Number is just the name I chose for the variable. Sky's the limit for naming your variables, except for a few rules that we will talk about shortly. The equal sign is the assignment operator, which will assign the value on the right to the variable on the left, so that whenever you use the variable name, it'll be pulling up that value, basically. And then 43 itself is, of course, it's just the value being assigned to the variable. And then also you can set the value of a variable using another variable or constant, which you can see in this example where we set the other number to number of steps, that constant. So yeah, the basic data types, we've already seen int for integers, which is basically any whole numbers. And then there's double, which is non-whole numbers, the ones that have decimal places basically. And then there's bool, short for boolean, which can either have a value of true or false, and that's in all lower cases. And then lastly, well, second to last technically I guess, is char, short for character. It is a single character enclosed by single quotation marks. Make sure you don't do double quotation marks. I've done that before, and it's, yeah, you don't want to do that. And there's an example there. Char final grade equals A. And then the actual last data type, what we're talking about, is a string. And a string is a sequence of characters enclosed by double quotation marks. But when you printed to the console earlier, that was basically a string. But the catch is with the string data type is that if you want to use it, as a variable, you're gonna need another one of those preprocessor directives included, like how we did for the a.out statement. So we're gonna let's look at that. All right, come back into our program. I should be actually. All right, we'll do this. Probably should have done this from the start. I apologize. So we're gonna include again, this time string, and then using standard string, and we can declare a string variable, just like all the other ones. String name Bob, and it won't yell at us. All right, so those rules we talked about for naming your variables and constants earlier, we're going to be talking about them now. And they're otherwise known as identifiers. So when we want to make good identifiers, so there's rules for the identifiers, and those are things you have to do, or else your program will not compile at all. So like you really do want to do these things, and those are that your name can only start with a letter underscore. It can only contain letters, digits, and underscores, and it cannot be a keyword. And a keyword is a predefined word in the language, like int that we've talked about. So anything that you use for other reasons, don't use it as a variable name, or else you'll have a bad time. But then there's also conventions and the industry standards for your identifiers, and you don't really have to do these things, but they're convention, and you should. And so those are like the variable names. So you see how I've been naming the variables. Looks maybe a little weird. I like to do the camel case here, but you can also do the snake case. The camel case is very the first word is that it's not capitalized, but every other word is afterwards. But the snake case is it has underscores between each word. And then constants, they should be in all caps with underscores between the words, as you can see in the like so. And you should try to name your identifiers something that describes what data they are holding. So, so you try to avoid vague names for your identifiers if you can. It helps make your code more readable. And in a similar vein to that, don't go too short or too long. Right. And then comments. Yeah, here's an easy one because it's not actually real code. Comments are lines in the program that do not actually affect the program when compiled or executed. And they're useful for documenting your code. So there's single line comments, which you'd use the double slash at, before you write your comment. And then multiple line comments, they'll have a slash and then an asterisk at the start, and then an asterisk and a slash at the end to end it. So now we're here at the end, and let's have some practice. So what I'm going to challenge you to do now is, assuming you got everything set up, I'm going to challenge you to write a program that declares constants and variables for all 5 of the data types we discussed now. And then first I want you to print those 5 variables to the constant so their values can be seen. And then afterwards set the 5 variables equal to the value of the appropriate constant, and then print them again to the console. And then while you're doing that, use legal and conventional identifier names and document your code as you will need to. So like if some random person looked at it, they realize like yeah, I know what that's doing. So yeah, try it yourself now, and I'm going to start writing this myself, and come back and see how similar yours is to mine. So let's do this now. Let's see. All right, I'm going to make sure to do it full screen this time so that we can actually see what we're doing. So we have our preprocessor directives, and as I said before, you want to have your constants out here. Const to int. Let's see. I don't know what to name this. Number. Stuff doesn't really matter. I'm just, let's see. Const double. Double is our decimal places, so we'll take advantage of that. Cache, I guess. That's how much. Let's see. Free dot. Right, and then character. Do grade again because I'm uncreative. Make sure to use single quotes. And lastly, our string. String. Complete. This will be the last thing we print, so that's why I'm naming it like that. Print the value I'm putting it. All right. Now our actual variables will go in the same order. Int first number. Let's see. Make it a fun number. And then our double. Gravity, sure, why not? There. Then bool. Other flag. Make it false. Sure. And then our character. Bad grade. There you go. An F. Because why not? Alright, so we got our variable names. We'll get rid of this a.out statement. Now we'll write another one. Let's see. Okay. So we'll try to label these. Let's see. Integer value, put a space, and when you want to have the variables in with your cout statements, make sure to separate that and the string parts. So I have my string part there at the beginning, and then I'm going to put my first number, and then we'll do our \n for a new line. We'll do double value. Let's see. All right. Then gravity, and we'll keep doing this. Probably should have chosen names that I'd remember more easily, but that's okay. Character value, bad grade. Okay, this won't make much sense when we replace it with the A later, but that's fine. And then lastly, our string. Let's see, name. I guess we'd probably put a couple of these new line characters at the end. Or if you don't like these new line characters, by the way, there's another thing here, and there's a IO stream and L, and that basically does the same thing, except you don't use it with the strings. So like after this, for example, if we didn't want to end L and L, that does the same thing. All right, so that's our that printed out, and you might want to actually, let's see, make this look a little nicer. There we go. So it's not one big line. And now we're going to change the variables to the values of the constants as I assigned. Make sure we get the right ones. Gravity equals cache. This doesn't make any sense at all. That's okay. The point is, we are replacing their values. And lastly, name. All right. Then we can just copy this because it's using the same values. The values which read the same variables, but they have different values now. Hold on, I copied that wrong. There we go. All right. So I think we're good. Oh, hold on. I did say to document it, I suppose. So I'll do some basic documentation. So a single line here. Declare constants. It's probably a bad example of a documenting. But with more complex stuff, you definitely want to document. Initialize variables. Yes, right. Declare and initialize constants. And then display variable current values. Update variable values. Display variable values again. All right. I guess if you want to see a multi-line comment, there. Mine automatically did it for me, so just put whatever you want here. Wonderful program brought to you by tutor. There we go. All right. So now we're going to compile this, and hopefully I didn't do anything wrong. Otherwise, that'll be really awkward. Oh, did it? Oh, that there's a constant. Alright, no one's perfect, no one's perfect. Alright, now it's fine. There we go. I don't know why I did that. Alright, so hopefully... Alright. Let's see here. So we have our first values printed, integer. Oh yeah, I guess I should mention when you print out a Boolean, it's either going to print out 0 if the value is false, or 1 if the value is true, rather it printing out false or true. So yeah, that's something to keep in note. But yeah, this is my program. Hopefully you got something similar, probably with better names and values. But hopefully you understand how to initialize these things and how to update them and how to display them. That was the point of this. So yeah, that's it. Thanks for watching. I'll see y'all next time.